Welcome to your video on graphing quadratic equations in factored form. Since I'm afraid this video is going to get a little bit long, I'm actually going to split up the notes into two parts. The first part is just going to kind of cover the background and terminology, and then the second part will actually go through the process of graphing. So to get started, we are going to look at the definition of a quadratic function. And sometimes I'll say function, sometimes I'll say an equation. They both really mean the same thing. And what we're talking about is that standard form equation. Y equals ax squared plus bx plus c. So we're used to looking at this because we've been factoring things in this form. Now, since we're transitioning to a graph, I want to bring back some vocabulary, independent variables and dependent variables. So when we look at this equation, and anytime we make a table of values, we are using x as our independent variable and y as our dependent variable. The reason for this is we can choose values for x, but then once we choose a value for x, the y value depends on that selection. So we are going to graph what's called the parent function. And this is considered the most basic parabola. If you weren't familiar with that vocabulary word, a parabola is another name for the graph of a quadratic equation. So if you recall, when we make a table of values, we put the equation in the middle, and then we choose values for x that we want to substitute in for. And in the past, our go-to values have been -1, -2, 0, 1, and 2. So let's go ahead and use those. Now we have to be a bit careful. And anytime you're going to be using an equation now that's got a square, I always want you to put parentheses in so that when you enter this in your calculator, you get that parenthesis correct. So for example, I'm going to do y equals, I'm going to just set up kind of the format of what I'm going to substitute in. So I'm always using this equation, y equals x squared. But what's going to change is what I put in for x. So in this first example, in this first line, I'm going to put in my -2. Well, when I square a -2, now some of you, if you pause this video and put it in your calculator, you're going to end up with a -4. But that's because you didn't use parentheses. Because remember, a -2 squared really means -2 times -2, and two negatives make a positive. So that would give us 4. In the next line, we are going to substitute a -1 for x, and a -1 times a -1 is a +1. Then we put in our 0, which obviously is 0, and then we'll put in our 1 and our 2. These are a bit easier to do. 1 squared is, whoops, I said 0, but I wrote 1. Sorry about that. 1 squared is 1, and then 2 squared is 4. So we're going to go ahead and plot these points. And so when I go over to my graph, I graph the point -2, 4, and then -1, 1, 0, 0, 1, 1, and 2, 4. And so you can see that there's a curve, and we want to make sure that we're doing this smooth curve. It shouldn't be a pointy graph. It should definitely be kind of a U-shaped curve. We still put arrows on the end like we did with lines to show that it continues forever. But then there's kind of been this key point that we've been talking about, and that is right here, kind of that turnaround point. That is referred to as the vertex. And you may notice we have a star by our table of values. We're going to want to always set up our table of values so that our vertex is in the center. Because if you look at the graph, the vertex is sort of in the center of the graph. Which brings us to some vocabulary. So we're going to fill out this chart. And remember, this chart just refers to the parent function. These values could change a bit once we have different equations, but all of the vocabulary will mean the same thing. So for our parent function, our vertex is 0, 0. And I'm just going to refer to that as the turnaround point. So where does our graph change from increasing to decreasing or vice versa. So the turnaround point. You may also remember that that vertex, that center point, is halfway between the zeros. And zeros are what we were finding in our last unit for factoring. When we would do the zero product property, we were always trying to find those x-intercepts, and that vertex is always halfway between those x-intercepts. Now, the minimum point is going to be the lowest point on our graph. So I'm going to go back to the previous slide here. The min also happens to be the vertex in this case. So our minimum value is 0, 0. I want you to note, though, that a parabola could have a maximum value if its direction was the other direction. So we'll write here a parabola could have a max if it opens downward. So an example, this would then be a max, but it's still going to be the vertex. So regardless of where the vertex is and which direction the parabola opens, it's always going to be either a minimum or a maximum. Now, the next vocabulary we're going to look at is the equation for the axis of symmetry. So I'm going to go back to our previous slide, and we're going to look at our graph. I'm going to grab another color here. Whoops. Didn't mean to do that. Sorry. No fill. There we go. I want to pick up my marker first. Now I got it. All right, so I'm going to do a green line for this. So if you look at our parabola, our quadratic here, you should notice that there is some symmetry. You can see it in the table where the y-coordinates are the same, and also here and here. But you can also see if I were to fold my graph over along the y-axis, the right-hand side would match up with the left-hand side. And this is what is referred to as the axis of symmetry. And so our axis of symmetry is always going to go right through the center, and so it's always going to pass through the vertex. And so when we talk about the axis, we're going to refer to it as the vertical line that passes through the vertex. Now, because it is a vertical line, you should be able to write the equation for that vertical line. And if you look up at the wall, we see on our word wall here, a vertical line is x equals whatever x1 is, and x1, y1 would be the coordinates of our vertex. So our axis of symmetry is just x equals 0. When we start to get into graphing, it's going to be helpful if you graph the axis first, because then everything else is going to kind of fall into place. Our next vocabulary word is zeros. Now, when we talk about zeros, this should be familiar. Zeros are just the x-intercepts, where the graph crosses the x-axis. They are also what we were working on in our previous unit. They are solutions to the equation ax squared plus bx plus c equals 0. So if you use the x method or difference of two squares, however you factor, those answers are going to give you the x-intercepts. Now if we look back to our particular graph here, the 0 is also the vertex, which is also the min. Now remember, this is only true for the parent function. It's not true for every parabola, but just for this parent. And so the zeros of our parent function, we just have one, and it's the vertex. All right, degree is another vocabulary word that we have been talking about. And degree is always the highest variable on the exponent. I just said that backwards. Sorry. It is the highest exponent on the variable. And so the degree of a quadratic equation is always going to be 2 because we're always going to have that x squared term. Now, sometimes we talk about how does the degree relate to the number of zeros or the number of x-intercepts. The degree is the maximum number of x-intercepts. So a quadratic equation with a degree of 2 can have at most 2 intercepts. Now you'll look at our parent function and it only has 1 intercept. So that is another possibility. But then it is also a possibility to have no intercepts. So if we just draw some pictures here, let's draw 3 sets of axes. And let's draw our 3 different cases. We could have a parabola that has 2 x-intercepts. So here's one and here's one. We could have a parabola that has 1 x-intercept. I'm going to draw this one upside down just because I can. So if this one just has 1 x-intercept, that would be the vertex. And then I could have a parabola that has no x-intercepts. So it could just be shifted up so that it never intersects. So this would have 2, this would have 1, and this one would have none, or 0. All right, this concludes just the introduction to quadratics and some of the vocabulary. Once you are done with this video, if you have time, you can continue on to the graphing portion.